Greetings, fellow Earthlings. Last time I checked, it's still today. So today is today, and today I'm still looking at the Earth and trying to process all this from the perspective of a single event, as Michael Steinbacher described it. And I started to consider throwing the moon at Pangea Earth to see if we could redistribute the landmass based upon some kind of collision with the moon. And I knew we needed a lot of watts because there are distinct patterns to me that indicate the electromagnetic force got involved specifically into this equation, not just force equals mass times acceleration. I see distinct electrical scars. I had talked about how this to me looks like a sprite. All these jets come in this way, and it's at low pressure right here. There's a band of a boundary layer, band of resistance, and then you get this fractal branching inward, 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 and on this side, the waters are carving in. The land is accumulating on this side and carving in. But the point is, I was going back to consider the different orbits and the different trajectories, how we can get our moon to cross paths with the Earth, and which way, what's going to be the best way that plausible too. We got to think of plausible scenarios, in my opinion. So I'm looking at this orbit. One way you could have the moon being a rogue object and just at any which way it could come in and strike the Earth, and as long as we get these scars, I'd be happy to accept that as a possible thing to consider, in my opinion. So while I'm doing this, there would also be the chance of an elliptical orbit. If you have two objects, one of them's, they're both orbiting the same object in this equation. So I basically wanted to consider different potentially plausible scenarios. So in this equation, you have one object, and then the other one would come in, and it might cross paths here, or maybe it comes back around and cross paths here, or maybe it extends out and you get 4 times where the path might cross between 2 or more objects. So that was another one that I considered while I'm trying to figure this one out. But in those equations, you got to think, if this, you would have to try and get it, you need to get the most power we can out of this equation, because we have electrical scars, in my opinion, very distinctly, and this entire landmass seems to be cohesive. So if this was a single event, I would suggest going back here, considering a time before we had a moon, and just taking our moon and throwing it at the Earth. Brought up this so you can get an idea of some of the scales of the planets that we have to work with in our equation. We have a few, these are the larger gas giant planets. I don't know how close to scale this is, but in comparison, we're very tiny to these two, moderate to these two. But when you look at, these are the terrestrial bodies, somewhat relative to scale, I'm sure. Our moon is within the range of some of these. So when you go out and you consider that, the chance that maybe our moon was orbiting one of these. And that became really interesting, because in that equation, I started to notice there's a very unique way to maximize the amount of watts we can get out of this equation. And I didn't even realize it at the time, but it kind of led to another breakthrough, which I was not expecting to even consider, but it goes back and you have to consider another portion of this world where you have this feature running north to south. And some of these features down here coming up and in, and this over here. What's all this about? So perhaps these were later events, but if this might have all taken place at once, so imagine this. We're going to take these two objects. Consider this to be one of these four potentials, perhaps. And in this scenario, whatever the Earth happened to be orbiting, could be the Sun, it could be Saturn, it could be Jupiter, it could be you name it, any one of what we have here, because this is what we have in our observable area. We'll just say that. Trying to base this off potentially plausible scenarios. So we have these four gas giants. We can consider the elliptical orbit, but we'll just stay focused on this for now. Come back here. Now you have one of these larger celestial bodies with, let's say this is our moon, orbiting around this one. And then you have our Earth orbiting around this one. And what if these two were to somehow get close? Like maybe their paths might have crossed somehow. And when you go back and you revisit Saturn theory and consider that potentially Pangea Earth might have been orbiting a different star, and you consider maybe this crashed into our solar system. I'll explain more about this later, because how you get from this to this, actually that just might be a matter of a different potential reacting upon the world, like out in space in the interstellar medium in between the main sequence, outside the realm of the sun's heliosphere. You might see reactions like this out of some of the gas giant planets. I'm going to talk more about that later, but just considering that as a possibility, as one of these crashes in, or maybe one of the gas giant planets got too close to the sun in the early times, and you have a situation where these two got too close, their paths don't need to cross, but as this one is getting closer, it's still orbiting like this. And if you take that same orbital path over here, and if this one's coming in, now in this situation, think about this, they're going to meet somewhere in this middle. And when they meet in the middle, this one down here, you're coming up around and in here. And over here, you're coming down and in over here. I think that's a very unique way to maximize the amount of this we have. We need a lot of watts. And I think some of that force of motion will get converted into electricity. I'm going to explain more about why in another video. Once I began to learn more about the physics, it actually made sense. Because if you go over here, and if this object is coming towards this, and this is coming towards this, what you have is a situation where these two bodies are coming in at one another, and the spark gap would be decreasing. But you also have a situation where you have nearly a head-on collision between these two objects, and that maximizes the amount of potential to fracture the entire landmass. You start off like this, you throw a moon at it, and next thing you know, boom, you got Earth. It's a lot to process, but at the time, I was just learning of some of these concepts. Like this jumped out at me right away. But then in this situation, you got to think, this is going to happen while one's coming in here, and this one's coming down from around here. Coming up and around here. Down. Did I just go? Yep, I went in the opposite direction. But if they're both orbiting in the same direction, generally, they're going to come in to meet in the middle. And in our orbit, if our land's always facing away, then it comes in to meet on the side of one of the land. The one side of the landmass. And that's kind of what you see here. And I'm going to explain more about this. I'm going to talk more about other things, but I didn't even realize when you have this situation, you now put the Earth between these two potentials, and that opens up a whole nother realm, because here we are, and here this is. You understand? All right. Good luck, everyone. We're going to talk more in a little bit. Thank you, and bye-bye.